Hi everyone, I'm Nishant and welcome to my 10-minute tutorial on propensity score matching using my IPYNB final notebook. So in this video, I'm going to teach you what PSM is and why we need it, and then I'll show you the complete working implementation step by step. So let's go. So let's start with core question. Did giving customers a discount actually increase their purchases? That's the question. In observational data, treatment isn't assigned randomly. Marketers target loyal or highly engaged customers who already buy more. This creates co-funding, meaning the treated and control groups different in important ways. So yeah, so if we naively compare treated versus control purchase risk, the estimated is biased. That's why we need PSM to make the group comparable. Here we discuss what is propensity score matching. So propensity scores matching, let's describe in three different steps. So let's go with estimate a propensity score. A logistic regression predicts how likely each customer was to receive the discount based on covariates like loyalty, engagement, age, and marketing channel. So the next is match treated and control customers. We pair each treated customer with a control customer who has similar propensity score. Estimate the casual effect. So in this part, after matching, we compute the difference in purchase outcomes within matched base. This gives us the ATT average treatment effort on the thread. So yeah, in the next let's discuss what we will learn from this notebook. In the next session, I'll show you the entire PSM pipeline implemented inside the notebook, generating synthetic data, computing the Navy difference, uh, estimating propensity score, checking overlap, matching treated and control customers, checking covariate balance using standardized mean differences, estimating the true what is yeah estimating the true casual effort, and finally validating the IPTW and sensitive test. So now, yeah, let's go with the notebook and let's see how it goes and how the representation and explanation go. Okay, so first we generate data in the cell one. Here we can see, yeah, we generate synthetic data set of 5,000 customers. Each row contains covariates like age, loyalty score, engagement, and marketing channel. We also generate two important variables: treatment and outcome. Treatment is whether the customer received a discount; outcome whether the customer purchased the product. Importantly, loyalty and engagement influence both treatment assignment and the purchase outcome. This introduces realistic co-funding into the data. In the cell 2, if we go through this Navy treatment effort, we compute the Navy difference in purchase rates. Yeah, here we can see. Yeah, okay. Yeah, here we can see purchase rates between treated and control groups. We g- we get about 8.2 percentages. Am I true? Yeah, I think yeah. So around like 8.2 to 8.7. Okay, yeah. Percentage point increase for treated customers. Yeah, we can see 8.2. Yeah, yeah. So but look at the covariates. The treated group has higher loyalty engagement, so this 8.2 includes both the treatment effort and the bias from co-funding. This is why Navy comparisons are unreliable. So let's see in this. Okay, here when we go through this propensity score estimation, we train a logistic regression model to compute propensity scores, which represent each customer's probability of receiving the discount. We standardize numeric features and one hot encoded categorical variables for stability. Then we add a new column propensity score. This score captures how marketers targeted customers. If loyalty and engagement strongly predict receiving the discount, the model will reflect that. This is the backbone of entire matching process. So in this case, we can see checking overlap. Here we visualize overlap between treated and control propensity score distributions. We want their ranges to overlap, otherwise matching becomes impossible. In this dataset, both groups cover roughly zero point 0.2 to zero point 0.7, yeah, range. This means there are good comparable units across both groups. Because overlap is strong, matching is visible, and positivity is satisfied. In this case, yeah, nearest neighbor matching. So this performs one to one nearest neighbor matching with capable of 0.05. The caliper ensures we only match customers with similar propensity scores. After running the match function, we successfully match about like 98 to 100% of the treated customers. This is very match high match rate, which means our treated and control distributions had strong overlap. At this point, every treated customer now has a matched control customer who is nearly identical in observed characteristics. So in this case, we'll see like balanced diagnosis. Matching is only valid if it improves balance. So we calculate standardized mean differences SMDs before and after matching. Before matching, loyalty had an SMD of 28, I mean 0.28, showing so severe imbalance. After matching, loyalty drops to 0. I think 0.04. Yeah, 0. Yeah, around 0.0 to 0.05, and all covariates fall under the zero point 0.1 threshold. Uh, yeah, and then here we can see visualizes this in a log plot. You can see each covariate moving dramatically towards zero imbalance. This confirms that our matching successfully created comparable groups. And in this case, now we compute the ATT, the casual effect of giving a discount. For each matched pair, we subtract the control outcome from the targeted outcome and average the difference. The ATT is 7.8. Yeah, I can see it's, yeah, 7.8. In this case, it should be, yeah, I think like, yeah, 7.8 to 8 point, yeah, 81%. We also compute bootstrap, which is 63% to 98%, which shows statistical reliability. Most importantly, the true effect we built into the systematic data was around 8%, yeah, 8.2. And our estimate is nearly identical. This confirms PSFM successfully removed the confounding bias. And then in this case, we can see robustness using IPTW. We use IPTW because inverse probability of treating weighing, an alternative casual method that uses weights instead of matching. Our IPW estimates 6.7%, extremely close to PSM estimate of 8.2%. When two different methods agree this closely, our casual conclusions are more the thirstworthy. I mean, trustworthy. And then here in this case, sensitivity analysis. We run a sensitivity check by tightening and loosening the caliper. Regardless of caliper choice, the estimated ADT stays between 7 point yeah, it says, yeah, 7 to 80% to around like, yeah, 7.7% to 80%, 8%, yeah. uh, yeah, I think, yeah. Yeah, stable estimates across different settings shows our results are robust, not sensible to arbitrary parameter choices. Yeah, so in this case, we can see. Yeah, now we'll go through some exercise questions.